Herculean. Oh.
Class.
Here comes Stefan. He was crazy that night.
Okay, you have like 10 seconds. Okay, now check with the person on the other side of you. We still got a third of you either missing or adding an extra force. Or not following directions for the format. All right, time's up. You're scaring me, dudes. 40% of you are going to fail this. Follow the directions here. Follow the directions. Is there a planet nearby? Yes. 20% of you missed the Earth. She's your mother. Don't forget her. Okay. I said every object capable of exerting a force. I didn't say every object touching. If I said every object touching, would you include the planet? No. If I say every object including a force, step one, unless I specifically say deep space, Earth. A number of people told me that the 3-kilogram box exerts a force on the 5-kilogram box. Do they touch? Are they next to each other in contact? No, there is no force of 3 on 5. Now, if the 3 weren't there, sure, things would be different. If the 3 weren't there, rope B would have no tension. But that's box 3 pulls on rope B. Rope B exerts a force on the 5-kilogram box. And then the last most common mistake is that people forgot that things touch beneath as well. If there were no G force, if there were no force from the ground, the box would have to fall vertically down. It would be going down forever, phasing through the ground. The ground is touching box 5. The ground exerts a force on box 5. The correct answer is B, C, E, G. Question? Okay. Did you ask your classmate? Did you try asking her what she thought? Okay. If you disagree, look, I will try to remember to do that. But you can also ask me. I'm just standing up here. Okay, and if you disagree, well, I'm going to try to remember to do it. Okay? Sure. Okay, the next one, let's see if this works any better. And I'm going to remember at least this time. Google question B, list every force. Force acting on box 3. How do we list forces? Triplets, 3 letters. 3 letters. Every force triplet acting on this box. That's the 3 kilo box. That's box 3. Are you going to tell me single letters? No, if your classmate says single letters, I can't condone that, but you should tell them not to. Question. Yes. We're identifying these. The letters are A, B, C, 2, 5, 3, G, and E. Those are the only possible dealer feeler. Oh, can you also read my handwriting? If you ever have trouble reading what I wrote, no shame for that, ask. Okay, ready, set, go. No, I gave up on alphabetization. Same. I'd say opposite direction. B is holding that box back. Ropes exert forces in the direction of the rope. It is still attention.
Is there friction?
Not unless I specifically tell you. This is Google question B, not C. Okay, turn to your neighbor. I still got a number of people giving me single letters, giving me words. Also read the question that I wrote. Because you're the prettiest. I'll give you another hint, and that is that I did not give you any information or hint that there is friction in this problem. If there is friction, I'll give you an indication. Assume there is a planet. Assume there's no friction. Assume that things without masses, like strings without masses, are massless. Is it important? Oh. Eh. Hope she'll be back. Okay, time's up. Let's identify the things touching the three. I see a rope A, I see a rope B. I do not see a rope C touching the 3 kilo object. I do not see a box touching the 3 kilo object. The only two things attached on the horizontal direction to the 3 kilo object are A and B. I see a ground touching the object from beneath, and there's a long-range gravity force. So the correct answer here for every force acting on this. Oh, and what kinds of force? Actually, most people got the kinds of forces correctly. Just added extra ones. What I would have said is tension of A on 3, tension of B on 3, normal force of ground on 3, and weight force of Earth on 3. Yes. It is absolutely not okay. Surface forces are normal forces, and the ground, the little patch of planet beneath your feet, isn't big enough to gravitate you. Gravity is only between planets or stars and things near them. Yeah. Unless I specifically state friction, no. No. Yes. Maybe you're on an icy lake. I mean, maybe you're on roller skates. Some friction, sure, but there's going to be some drag. And you can ask, like if this is a really big honking force pulling kids along an icy lake, you don't care about the friction. So no, you do not always include friction. Okay. Let's try again. This is a missing thing. This is a big missing thing. Okay. Let's go easy. Let's go easier. Can you list every force? Let's make it easier. Horizontal force. Acting on box 2. Okay, let's keep it simple. Make it simple. Can you tell me every horizontal force in triplet notation acting on box 2? Box 2 is the box with mass 2 kilograms. It's not the second box in a row. Please read the instructions carefully, my friends. Mona, as I said, unless I specifically say there's friction, you can assume there's no friction. You must answer in triplet notation or it will be counted incorrectly. Okay, I'm still getting a lot of difficulty here with what objects touch what objects, as well as which direction horizontal is. Please turn to your classmate and identify which direction horizontal means. Please turn to your classmate and help them identify what things touch box 2. Gina, it's the same as every triplet notation. The kind of force, the dealer of the force, the feeler of the force. The contact forces are tension, normal, and friction. So the first letter must be T, N, or F. Every single one of these is the same way.
Yeah. There you go.
Okay, time's up. Let's go down the mistakes and how to avoid them. So one of the common mistakes that I see is that a fair number of people did not read or listen to which object we are studying. Not box 3, not box 5, box 2. Another problem is that a number of people did not read or listen where I say horizontal force. I ask you this, does gravity pull things sideways? Is the direction of normal for the ground sideways? Normal and weight are vertical directions, not horizontal directions. There is only one thing pulling the 2-kilogram box along, and that is rope C. The correct answer is TC2 only. There is no other horizontal force. There is no other horizontal force. TC2. Not TC3. Not weight of Earth on 3. Not weight of Earth on 2. That's just it. TC2 and that's it. Okay, I need help seeing where you're struggling. Um, if you wrote TC2, don't type anything at all, and do not type nothing, I get it, makes sense. Google question D, if you missed, and only if you missed this question, if you did not write TC2, please give me a short reasoning for where you're struggling. Again, if you wrote TC2, you do not have a Google question D. If you did not write TC2, if you wrote something different, then give me some explanation for where your answer came from, and I will try to help address that. Mistype, great. Okay, I'll take that. That's fine. Misclicked, okay. Sure, that's fine. Okay, I'll take that. Okay, here's a good one. Here's one that is muy importante. Why, y'all tell me, why does box 5 not normal force box 2? They're not touching. They're not kissing. They cannot kiss. They are separated by a vast chasm of space. 5 does not touch 2, 5 cannot normal 2. What if the boxes were running into each other? If you're pushing on the back end of this train, 2 smacks into 5, smacks into 3. Then there would be a normal force, absolutely. But if the 2 is not touching the 5, there can be no normal force between the 2 and the 5. I might totally ask you about the boxes pushing against each other. That's totally legal. It's just that's not what we got here. Question. Mm-hmm. Mm-hmm. If the rope is all loose and stuff, I would say no. And if you're pushing 2 against 5, that string can't be taut. Strings only pull on their ends, they don't push. There would be no tension. No tension, only normal. Yeah, let's see more goofs. I see a lot of mistypes. Good. I mean, sort of good. Mistyping means you're not being careful. Mistyping, misreading. I mean, no conceptual goof? Great, I'll take it. But you mistype on the midterm, you still lose the point. Mistype, misclicked, whatever. More than half of the people who missed it said that they just mistyped. Okay, watch out, y'all. Watch out. Be careful. Practice being careful with this. Okay. The next skill we're going to do is remembering Newton's second law. What's Newton's second law? And what's F stand for? Half second. What's F stand for? How do you find a total force? Add all the forces together, accounting for negative or downs and lefts, right? Okay. Do we know the masses, by the way? Is the acceleration known yet? No. Question. Yes, absolutely. I'm exerting a normal force on this wall. Normal just means right angles. You got a vertical surface, you got a horizontal normal. Totally. Absolutely. If box 2 is pressing up against box 5, you betcha. Always, always, always. If 2 pushes 5, 5 pushes 2 with the same kind of force. That's guaranteed by Newton's third. Nope. Normal, by definition, the word normal means right angles. Horizontal surface, normal is always vertical. Now, if there weren't a normal force, there would be no friction. Friction depends on the 2 surfaces being pressed together. But that doesn't mean normal acts horizontally. Yeah. Good questions. Other questions before we continue? Okay, so let's start simple. This is Google question E. I want you to write down F equals MA, applying the meanings of F and M. And you don't know A, so just write A. So what is this Google question E? Apply Newton's second law to box 2. You just wrote down, I should say, in the horizontal direction. Because there are 2 directions here. It's just the vertical is boring. Don't tell me about normal forces. Don't tell me about wave forces. And this answer is not a number, it is an equation. One more time, I want you to write down Newton's second law, plugging in what you know. I'll give you a hint. You don't know the tension. 3 different ropes do not all have the same tension. 3 different ropes do not all have the same tension. Tell me the Newton's second law applied to the 2-kilogram box. Also, a number of people are just giving me, when you're talking about the force, I want you to identify the force. There are lots of tensions here. Identify as we've just practiced identifying it. Yeah. Say that again. Does A touch the 2-kilo box? Then it doesn't exert a force on the 2-kilo box. The only tension on box 2 is C. If it weren't for this force, things would be different. But this no touchy that, this no forcey that. Always, 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 always. Unless you're a weight force. Okay, one more time, I would like you to identify a force by its full name. For now.
So you want it? Or like, do you want?
You haven't written Newton's second law, you've just written the left-hand side. What's Newton's second law? So where's the M, where's the A?
I don't know that right though. That's what we're doing. It's acceptable.
Not only acceptable, it is perfectly correct. I will give you a hint that when you're doing algebraic symbols, I never put units in there. Because then K and G, well, in this case, there is no,
I see.
I always put it when stating final answers.
If it considers, it's fine.
I'm giving it credit. Yes, you are. Okay, one more time. Please listen, please listen, please listen. We just identified the name of the force acting on box 2 horizontally. You should use that name when you are writing the net force on box 2. In the previous question, you identified the force acting on box 2. I've got a whole bunch of people dropping letters. Use its full name. There are lots of tensions in this problem. You can't just say T. There are 3 different T's. So use its full name, please, in this case. Another hint, I have a number of people using equations from other problems in this. You cannot use an elevator problem equation to solve boxes on a string, horizontal string problem. That's like saying I'm talking to somebody named George, and then the rest of the day I call everybody else George. George applies to this, not that. You can't use specific equations for one problem in a completely different problem. You can always use, there are only 4 equations that you can always use. F equals ma, static friction maximum equals mu Sn, kinetic friction always equals mu Kn, and weight equals mg. Those are the only 4 equations that we always have in this module.
Part of it. So if we're axing on box 2, the horizontal would be would it be, I feel like it'd be multiple, but for the one like we're focusing on would be the rope C, correct?
That's it. It's the only force. However, that's not the name of that force. How do we name forces?
Like 10
Letters.
Oh. Oh, okay. This would be for this example. We're just doing it on the box. Yeah. The tension force. Like that?
Yeah.
Oh.
Well, that looks like C squared. They're both substitutes. Yeah.
So do I add in the 2 kilograms?
You know the mass? You can plug in the mass. Absolutely. That's it. That's the correct answer. Okay, 10 seconds left. Give me your best shot. Okay, I am looking at about a third of the class passing the section. That's not okay. What format did I say to list for forces? Most of you got the previous question right. Most of you got the previous question right. And then 75% of you did not use, well, less than 75, 60% of you did not use the very previous question. What's the name of the force acting, horizontal force acting on 2? How do we name this? TC2, 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 not TENSION, not T, not F. As I said 3 times up there, please, please, please listen to instructions when I give them. Name it with the triplet that we just did. Let me see if you can apply that. I want you to say do the very same question that we just gave for E, but knowing how to state. I want you to write Newton's second law, applying the symbol that I just told you to do. This is Google question F. You have like 10 seconds. Do the same damn question, except write it right this time. You did it right. You're fine. No, you're not. You don't have nothing to be sorry about. You're good. Yeah, you're right. No. You don't have to do anything else. You're fine. I mean, go ahead and rewrite it again so I can. Wait. Yeah, go ahead so that I can see the percentage of people who are doing it right. And one more time. What's Newton's second law? F equals, am I asking you just to say F? No, I'm asking for you to plug into the appropriate equation, F equals ma. Not just say the left side. Okay, we're moving on. La respuesta correcta. If we are applying F net equals ma in the horizontal direction, then I know what F net is because we just said what F net is. And I know what the mass that I'm applying this to is. And as I said at the beginning, you do not know what acceleration is. So you use a symbol to represent it. FC2 equals 2a is the correct answer. Question? Yeah, two's. What? Okay. What? Wait. What? Hold on. Oh, yes. Good. Good. Not two, but TC2. Is that what you said? Yeah. That was a trick question, and he passed. Yeah. No, TC2. TC2 equals 2a was correct. Yeah.
And if F net instead of TC2, what's the difference? Like understand what TC2.
Because I said to plug in what each symbol means. FNet is generic. FNet's a pronoun. Who is FNet in this problem? FNet can be anything. In this problem, the only horizontal force is TC2. So if you're plugging in what you know about the problem, just like FNet equals m times a, but in this case, I know m. I'm talking about the 2 kilo box, m is 2. So whenever you have a problem where you know the force is acting, don't just write FNet, FNEAT, write what the forces are. Okay. Moving on. Here is one of the muy importante equations that we're going to use in a minute. Let me put him in a little box over here. Let me wait for, ask for questions about how we did this. What I'm asking for, notation, anything. I'd really, really like y'all to get 100 on these questions. Don't think I'm asking for something y'all can't do. Let's do this one more time for the 5, not one more time, we're gonna do this twice more. Do this for the 5 kilo box. Apply Newton's second law to box 5 in the horizontal direction. Okay, this is Google question G. G for golf. Look at the situation, figure out what horizontal forces act, what's M, yada yada. You tell me. You tell me if it applies to have a negative sign. Yes, it's G. You can tell it's G because I wrote G. Molto bene. Correct. Very good in Italian. You are doing the thing. Hey, what's the mass of box 5?
So, since theoretically, box, the rope B is, I don't know, would it be adding tension force?
Which direction does a rope going left pull?
I'm sorry, my processed me, what was that, I'm sorry?
There's a rope attached to your left side. Can that rope push you right? Ropes suck at pushing. There's a taut rope on your left arm. Which direction is that force? Imagine it. Physically imagine it.
So, like,
Here, let's do it. Let's do it. Let's be the rope on your left side. Yeah, here. Hold this rope.
Oh.
Hold this rope. Not your right side, your left side. Okay, that's positive direction. I'm the negative direction. Which direction do you feel the force? Exactly. Ropes, it's rope, strings, tension forces go in the direction the thing goes. If you've got a rope on your left side, you've got a tension force pulling you left.
So it would be adding them together then?
No, well, I mean, net is always adding, but the left is the negative direction.
So it's correct. Cool,
Adding a negative, subtracting, same diff.
thanks.
Good,
So I think helps as well.
good,
So,
that's right.
So is the reason it's plusing is because I originally thought the reason it's adding is because they're going the same direction.
They're not.
It's combining force. Well, 'cause
The
they're all-
boxes are moving in the same direction, but if you're pulled on both sides of you, you're pulled in opposite directions.
Those opposing forces will be minus because of that. Okay.
The right force minus the left force.
All right. All right. Want to understand this.
Okay, it looks like a number of people are confused which direction ropes pull. Let's address this for a second. Ropes suck at pushing someone. Ropes suck at pushing. If I've got a rope going off to this side of me, it doesn't push me this way, right? Ropes just slack if you try to push with them. If I've got a rope going off to your right, they pull me right. If I've got a rope pointing left from me, it doesn't push me rightward. It pulls me leftward. Which direction do we call the leftward direction? Okay, consider that. And you may change your answer for G. Hi, Grace's bedroom. That was hilarious. Okay, getting better. 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 Still not where I want you. Okay, let's demonstrate this step by step, inch by inch, millimeter by millimeter. Horizontally, there are 2 ropes tied to block 5. How many forces should there be on block 5? 2. There are 2 taut ropes attached to block 5. Which direction does a rope go? Does it push or does it pull? Yeah, that's what I just said. So the force of the block rope B, is that right or left? Positive or negative? The force of block C, is that plus or minus? Okay. What's the mass of the block that we're talking about? Hint, 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 hint. Okay. Did you all hear questions about what everyone just said? Yeah.
So accent going that is negative, and then word positive, I believe. So with the order of we do like negative t like t 5 and then plus.
Is x minus y the same as negative y plus x? 5 minus 2, negative 2 plus 5, they're always the same number, right? It does not matter. Ever. Okay, that's now 2/3 of y'all. Let's see if we could push it a little bit further, and then I'm saying screw it, move on. I've got a number of people saying that tension 1 equals 3A, tension 2 equals 5A, or tension 1 equals, wait, hold on. What's this goof? B equals 5A, C equals negative 5A. That's not Newton's law. Newton's law doesn't say any old force equals mass times acceleration. Any other old force equals negative mass times acceleration. Newton's second law, the meaning of this symbol F net is you've got to combine addition of the vectors that make up, that are pushing and pulling on this. As I said, there are 2 forces. B is pulling right, C is pulling left. If I incorporate the direction of this, the correct answer here is T B5. Please note, not TC minus TB. Which one is in the positive direction? B is to the right, on the right side. If you pull on something's right side, it moves right, accelerates right. TB5 minus TC5, not equals F net. That's not Newton's second law. That's just the meaning of F net. 5A, not 3A. Talking about the 5 kilo block, use the mass of the 5 kilo block. The mass of 5 kilos is 5 kilos. Here is muy importante equation 2. Let's try this one more time. We need this. Please turn to your neighbor and ask. We've got more than half the class getting this right now. So hopefully someone on either your right or your left side will get this. Pull your right side right, pull your left side, whatever. Being silly. Can you write Newton's second law and apply it for the 3 kilo box in the horizontal direction? You may apply the fact that TA3 is 100 newtons if you like. If you like, I would give credit either way. Please again, look which box I am asking you to analyze. Perfect.
Yeah.
No, thank you. Check yourself term by term, please. What is FDET? Ask your classmate. Which box are we asking for? Which is the mass of the box? And finally, how do you say a force name?
I don't.
Good. 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 Okay, we are up to now well more than half the class. The correct answer is TA3 or 100 if you prefer, minus TB3 equals 3A. The rightward force on box 3 is TA3. The leftward force on box 3 is TB3. When we add those together and incorporate the minus sign, TA3 minus TB3 equals 100, equals 3A. Okay, so now we have three equations. I have imposed the condition that they all accelerate together. Can anyone tell me why it's reasonable to say that they are moving together? Please. Yes. There's one word that I'd like to hear in there as well with the rope. With the what rope? There's an important thing about the rope. If this rope were a stretchy elastic string, couldn't they move relative to each other? I mean, everything could exert a tension. What I would say is a stretchless rope. Stiff. No, that sounds like it could push. Stretchless is the word we usually use. Since the rope cannot change length, it's not a spring. We haven't done springs yet. Wherever the 2 kilo box is, it's this much behind the 5 kilo box. They are moving together. The 5 kilo box can't accelerate faster than the 2 kilo box, because then they wouldn't be moving together. So I've used the same symbol A for all of these. Next thing, what do you know about the force that a rope exerts on left end versus right end? Which one pulls harder? The left side or the right side? No. They're equal. Ropes, tension force. The nature of a rope is the tension it pulls on either end is equal. We call this the tension in the rope. The force that it exerts is equal to the force on the right. I skipped over this explanation with the 3 o'clock. They got it wrong too, but I skipped over this explanation. Let me try out the explanation for you. Suppose there are two forces acting on a rope, a right force and a left force. What's the net force? No, right minus left. The net force, if there are two things acting, a rightward and a leftward, would be right minus left. What's the net force always equal to? Sum of the forces, and that's always equal to MA. Now here's the thing, yo. We haven't talked about these ropes having any mass. Ropes, strings, cords, we usually treat as ignorably small. I never have given you a mass for these to analyze with. If I did, if this were an anchor chain, sure, then there would be a mass and the left and the right forces could be different. But for a rope being pulled on either side, if M is small, right minus left equals 0A. What's 0 times anything? If R minus L equals 0, what's bigger, R or L? Neither, R equals L. So assuming that the rope is of ignorable mass, and that it's only being pulled on two ends, you can say that the tension of the left is equal to the tension on the right. So TB3 and TB5, which is bigger? Neither, they're the same force. B pulls on 5, B pulls on 3, pulls it in opposite directions, but it's the same magnitude. Okay, you have 3 equations in 3 unknowns. You don't know the C force, you don't know the B force, and you don't know the acceleration. I challenge you to a duel. I challenge you not to a duel, but I challenge you to be able to plug in and solve algebraically. Can you plug into an equation and find, let's say, acceleration? Google, you better be. Here's question I. Question I, find the acceleration given these 3 equations. Check if your algebra is not solid. I encourage you, write down every last step. And as you do each step, think, am I doing the same thing to both sides? Am I conducting a legal algebraic expression? So Google question I, given these equations, solve for A. You will get a number. I want a number. Give me nothing but a number for acceleration. Nope, it's not. Rope A, rope B, and rope C are all under different tensions. Yeah, that's what I just said. If the rope is effectively massless, if I don't specify a mass of a rope, then it pulls on the left side and the right side equally. Hey, tell me units too, by the way. I'm asking for acceleration. Let's see if you remember what acceleration is measured in. Ooh, someone could type the squared. Also, please check your neighbor before you wreck your neighbor. Help him out. Gesundheit. If you're struggling, do it on paper.
this how you do it?
Mm-hmm.
Okay,
Good,
Okay.
good. You are on fire today. Good job. Keep it up. That girl is on fire. I will give a hint again if you are lost where to start. You have three equations. You know what TC2 is. You know that TC2 is equal to TC5. You know what TB3 is. Here I've given you a big fat hint. I've solved TB3 for you. I have an equation involving these unknowns. The big idea behind algebra is that you can plug symbols in when you know their value. Do it. Simplify and solve for A. Also, if you are very confused, check with your neighbor. They may know something. Again, algebra carefully. I'm looking for a number, not an algebra. Again, the hint is if you know what these symbols mean, you can plug them in. You know that TB3 is 100 minus 3A. I gave that to you. I solved this third equation for you. You know that TC3 equals 2A. You can plug things in if you know what they're equal to. Solve this for A. Carefully.
A little differently because instead
There's more than one way to do it.
since all these are pulling at the same tension, I did that for this equation.
They're not all the same tension.
Oh, they're-
TC5 equals TC3. That does not say TC equals TB3.
Oh,
Does not to say it's TB equals TA.
dang.
I accidentally put it in,
Yay!
accidentally put it in as,
Pluses?
no, I did as 2A minus 100 minus 3.
Yep. Careful.
I did text that as, wasn't say that down.
Okay, the final step is I think if I add 3A and 2A to both sides, I can get rid of the minus 3A and the 2A. I am left with 5A, 3A, and 2A added together. What happens if I add 5 of something, 3 of something, and 2 of something together? I think that is the same thing as adding 10 of something together. At the end of the day, I could divide by 10 on both sides. 100 tenths equals 10 meters per second squared. Yes, you are. Adios, everyone.